Static member in the class works a little bit differently, but you can use that one to trace how many objects of the class has been created and the like, or how many objects are left over by the end of the function call and the like. So let's go back to student class, and then here let's define static member. uh, let's call static int count and like then static member in the most recent C++ compilers allows initialization like this, but to make it compatible with all the C++ compiler, then if you declare a static member, you need to give a special declaration in .cpp as well. If you remember from the earlier lesson, then in .cpp we need to declare integer variable called the count is in student class can initialize to 0. So this declaration is required. Here is a typo there. So that's how to declare static member. Then if you recall from earlier lesson that as I create the student object of S1, then S1 will have a GPA and ID, and then this static member count will never ever in student object. If I do S2 as another student object, it will have a GPA and ID only. Static one never appears, but static ones are in special area outside all of those objects. So the area in the computer memory called the heap, in heap area this count variable is created, and but this count variable belongs to the student, so we have access to this variable with the class name colon variable name is how we can have access to that. So count variable is created only once, only one cap is there, but GPA and IDs are created every time you create object of a student. So that's meaning of a static variable in the class. So using that, what you could do is in the constructor, we didn't give any constructor at all, but we can explicitly give like a default constructor or constructor with GPA only, or constructor with ID only, or constructor with both GPA and ID and the like. We can give a variety of constructors, and also we could give a destructor when the object dies. A destruct is called. So here in student class implementation, we could give a constructor. Default one is GPA 0, ID 0. Like then another one is GPA only. Then GPA is assigned. Another one is ID only. Then GPA is 0, ID is I. Another one is with both GPA and ID, then we give GPA and ID accordingly. And the destructor is something like this. So what you could do here is that in this constructor, let's just increment count. Since the count variable is static and that count variable is not created for each object created, but it's created outside any object just once. So if I increment the count, then as an object is created this way, count is incremented. Or student's object may be created by this constructor or by this constructor or by this constructor. When the object dies, we can decrease the constructor, so that when if a function just deals with lots of student object creation, then at the end when the function ends, we can monitor if student's object count is 0, then creation and then deallocation is properly done. Otherwise, if count is not 0, deallocation is not correctly done. So we can monitor the student count there. So in application, it would be something like this. So let's create another file just for declaration, ex3.cpp. So include student class declaration. So what I want to do is as follows, and student, I want to display the count in the program wise. Then we need to provide a function for that, a public mode. So let's do int get count const, but let's declare this as a static there. And the static const is meaningless. Const is a non-static function which does not change any member variable. So since it is a static one, and the giving const is error, as you saw that. Now int count function should be defined. Int student get count, which should simply return count is there. So in ex3, cout number of student objects created so far, created alive is we can call student colon get count, which is a static function, so we can call this way, include iostream using name space std, like that. And if I create student s1, and let's use a pointer, s1 is new student, the default construct is there. Then after that, if I print, then this is what you get. So in makefile, let me give ex3, but to make it very short, let me give a label 3 and ex3.cpp. I want to compile x3.cpp, and I want to have output as 3 only, like that, so that I can quickly type it. So I'm just showing you, this is not very readable though, but when I type it, I want to just make it very short. So that's what I did. So I don't make 3. There is an error. So here, student reference from, and there's a not found. Yeah. Okay, here ex3 uses a student, so I should have given something like this. ex3 3 needs ex3.o, and the student.o is needed, and then I could put together student.o there, and then now I need to give a dependency. So dependency, so ex3.o is by compiling ex3.cpp, which include the student.h, g++, compile only with the debugger symbol, ex3.cpp. So we need to give this step. So if I type make 3, then once those two .o files are present, we put together to produce this executable code called the 3. But if you are using Windows, you should give 3.exe, the suffix is required, but in Mac or Linux, a suffix is not required, so you can skip that part to type it short. But let me use keep 3.exe. Then if ex3.o is not present, then go through this process. So let me make 3 again. Then 3.exe is created. So 3.exe is how to run that. So students, number of student objects 0 and 1. That's what we expect. But here, if I create student S1, student pointer S2 with a new student with 3.5 GPA only, and student class set the GPA is in float type, and 3.5 is a double type, so we need to give a floating point number with a suffix f. So make 3 dot exe, then objects are now 2. Then if I do delete S1 and then see what happens, make 3.exe, now 0 to 1. At this moment 1 is deleted, it's now 1 is left over. So, and the like, so utilizing static member, which is incremented at every possible constructor, and which is decremented at the destructor, then something like this, you can tell if you are dynamically creating those objects, but at the end of the function, then you can check how many students objects are still alive, not deallocated yet. So by doing so, you can check whether you have a memory leakage or not. So that's another usage of utilizing a static member in class.